So here's an example from baseball. So you make contact with a ball 1 meter above the plate and you launch it at an initial velocity of 36.5 meters per second at an angle of 30 degrees from the horizontal. The center field wall is 113 meters from the plate and is about 3 meters high. What time does the ball reach the fence? And do you manage to hit a home run? So there's a lot of components to this question. The first thing you should always do is like sketch a little bit of a diagram here. So we're going to start off with our ball makes contact 1 meter above the ground or the plate. We're looking to go 113 meters. So this is our dx, 113 meters. Let's say the wall is here and it's 3 meters high. And really the question is the ball able to make it over the fence, right? And we can also label our initial velocity, which of course is going to have x and y components to it. So let's start with just our horizontal component, or sorry, our vertical component. That'll be one of the easiest places to start. So if we write down everything we know in the vertical kind of direction here, we know that our initial velocity, or the y component of our initial velocity, is 36.5 times sine 30, which gives us 18.25 meters per second, and that is in the up direction. So again, as normal, up and forward are going to be positive, down and backwards or down and to the left are going to be negative. Unlike normal questions, we're actually not going to solve our time using our vertical components because as you can see, we're kind of stuck here because we don't really know um, what's going to happen and if the ball makes it over the fence. We could, of course, solve for when ey equals 0, but that's not really what the question is asking us to do. So we're going to take a stab at the horizontal data and see if that's going to give us some information that we might not always, that might be a little bit different from previous examples. So our v1x is, as normal, going to be 36.5 times the cosine of our launch angle, which is 30. So that gives us 31.6 meters per second in the forward direction. And we actually do have an extra piece of horizontal data here that we don't normally get, and that's our dx. Because we know that the ball, or we're looking for when the ball travels 113 meters in the forward direction. So take a hint from the question here, right? It says what time does the ball reach the fence? So that's a horizontal question. So we're going to use our horizontal data to kind of analyze that. So we're going to do that up over here. We know that our time is equal to our horizontal displacement divided by our vertical velocity, or sorry, horizontal velocity and horizontal displacement. So that gives us 113 meters divided by 31.6 meters per second. Time is always a scalar value, so we don't we don't need to include any directionality there. That gives us 3.58 seconds. So we would say that it takes 3.58 seconds for the ball to reach the wall. Now, this doesn't tell us if the ball goes over the wall or not. We still need to do a little bit more math to figure that out. Okay, so here we have the information from the previous part of the question. So we have the time, and we also just recall the vertical velocity because of course we're going to need that. We also do have hidden in the question the vertical displacement, at least the initial displacement. So we're starting 1 meter up from the ground. So we can use all of this information to help us solve for whether or not we're above our wall at the 3.58 second mark. So to do that, we need to recall that we have this equation here, right? So the change in y displacement is equal to the initial y velocity times time plus 1 over 2 times the acceleration due to gravity times time squared. Now, a really important part here is that the change in dy is just equal to the final displacement minus the initial displacement. And then we keep the right-hand side of the equation the same. And that's true for any sort of change in, right? Like the change in velocity is v2 minus v1, the change in time is t2 minus t1, so the change in displacement is d2 minus d1. I want to put everything that's not d2 on one side, so I'm going to move my d1 to the right-hand side of the equation. And this should look really familiar as this is essentially another quadratic equation almost in standard form. So I'm going to plug in everything I know. So this is 1.0 meters plus 18.25 meters per second, and my time is 3.58 seconds. Plus, I'm going to move this just underneath to make space, 1/2 negative 9.8 meters per second squared times 3.58 seconds squared. If I take all of that and plug it into a calculator, you're left with d2y is equal to 3.5 meters off the ground. Since that is higher than the height of the fence, so since d2y is greater than 3.0 meters, Carlos gets a home run.